What's up, math scholars? Got a busy day today because we're on connection schedule, but we'll be able to teach it all to you. So it's 1/6 performing operations with complex numbers. We get to be introduced to the world of imaginaries. Who's excited? Woo! Yeah, imaginary numbers. You can't even see them. They're like little ghosts. They don't actually exist. So something to write down is what the imaginary unit is. It's called I. They kind of curl the bottom of it for whatever reason, so get used to that. But the square root of -1 equals I, and you can do calculations with I, such as finding out what I squared is. If you would do I squared, you would just square the square root of 1, and you'd get -1. All right, so we're going to use this newfound knowledge to solve this equation. Traditionally in the past, you'd solve this equation, you'd get to the point where you'd have to square the negative, and you would stop, and you'd say no solution. But now that we have this imaginary unit that we can use, we will be able to express our answer with imaginary numbers. What do you guys think step 1 is going to be? -11 on both sides. I'll go grab my calculator and give you a second to catch up. No. So it's 2x squared equals -48. What's our next step? Divide both sides by 2. That gives us x squared equals -24. And what's that last step? Square root. Now we don't want any decimals. We just want to kind of simplify this radical down. So first things first. You can't square root negatives, right? Not possible. So our answer is going to be imaginary. The way I picture is I picture this negative sign kind of popping out front and becoming an I, because the square root of -1 is I. And that can leave me with just a normal square root of 24. And now let's work on breaking guys out of jail. So how can I break this 24 down? 6 times 4. 3 times 2 and 2 times 2. So it looks like the square root of 4 equals 2, so that's why that 2 can get out front. The way you write that, you want your positive or negative, because you did use a square root. You want the 2 written first and the I written next. I think they just do that so it looks nice. It would be weird writing I2, but 2I, it looks a little bit nicer. And then you're going to have radical 6 still in jail. So it's plus or minus 2I radical 6. Any questions on that one? All right, I had the video on pause and we briefly talked that the term complex number means that the number as a whole has a real section and an imaginary section. So I want to kind of show you this problem here. What you're seeing here, that 6 is a real number. And what you're seeing right there, that 5i is an imaginary number. And together they make something called a complex number. So the reason you're seeing these parentheses, this is not a foiling problem, but the reason the parentheses are there is just to show you this is one complex number, and this is another complex number, and we're going to add them together. So it's this easy. You add together the real parts, and you add together the imaginary parts. It's just like using like terms. So the 6 and the 2 are the 2 I would add up. Those are my real parts. You're going to get 8. It's a different color. The 5i and the -4i, those are the imaginary parts that you're going to add up. And what would that give us? Positive 1i. Okay. You can write 1i or you can just write I. And that's your answer. We always want to express our real parts first and our imaginary part second. And this answer could be called a complex number. So it has a real part and an imaginary part. All right, we definitely want to look at a subtraction problem where we have to subtract these complex numbers. I feel like we've already talked about this concept this year, but what happens when you have a negative out front of a group of numbers? Yeah, we've done it, right? In my mind, we've done that. So we're going to take this negative, distribute it to the 7, so that will become a -7. That's a real number. And then you'll distribute the negative to the -4i, and it will become a positive 4i. That's an imaginary number. And I'm going to add it to 2 plus 3i. That remains unchanged. It did not have a negative distribute to it. Let's go ahead and add up our real parts. 2 plus -7, or 2 minus 7, would be -5. And then 3i and 4i, 7i. Pretty easy so far, right? All right, so we've done one adding, we've done one subtracting. It's time to do a multiply problem. We're going to do both of these. It says to multiply two complex numbers, you can either use distributing or foiling. But the key is sometimes when you do these distribute problems, you'll get an I squared. And what did we learn that I squared equals? -1. So it's almost like I squared is our gateway from imaginary world back into the real world. Isn't that cool? You can actually turn an imaginary number back into a real number if it's an I squared. So I always tell my students, when you see an I squared, it's like a little alarm should go off in your head. Whoop, whoop, whoop. Replace that I squared immediately with a -1 to make it a real number. But go ahead and jot down part A. We'll try that. You'll see what I'm talking about with that I squared. All right, so 4i times -6 is -24i. These i's behave just like variables would. And then 4i times I is 4i squared. Whoop, whoop, whoop. There's an I squared, everyone. What do we do with I squareds? We replace them. So basically that I squared gets replaced with a -1. The 4 and the -1 would multiply together with one another and become a -4. So my final answer I would want to express with that -4 out front because that's my real piece. And then my -24i second because that's my imaginary piece. And again, our answer has a real component and an imaginary component, so it's called a complex number. Did you follow how that I squared worked where we replaced it? Awesome. We get a chance to practice it again in part B. Part B, let's go ahead and do a FOIL. We have 4 rainbows to draw, 4 multiplications today. 9 times -4 is -36. 9 times 7i would be a 63i. Ooh, be careful. Beware of the double negative. -2i, -4, +8i. And then this is the tricky one with the I squared. It's a -2 with a +7. Both of them have an I. So it'd be a -14i squared. Whoop, whoop, whoop. There's an I squared, everyone. What do we do? What do we do with that I squared?
Make that a -1.
Make it a -1. So if you replace this I squared with a times -1, what do you get when you multiply -1 times -14? +14. Let's go ahead and add those two up in this step. 63i and 8i is 71i. And then we can add that 36, -36, with that 14. What is -36 plus 14? That's what I think so too. And we're going to put that out front because that's our real part of our answer. And the 71 is the imaginary part of our answer. I'm going to have all the kids in here try this one all by themselves. Maybe we can even find a brave soul to teach the class in a few minutes. We'll see. So pause the video and try this by yourself. You're the teacher. All right, I have a teacher up here, everyone. Miss Clark, go ahead and teach class how to do this.
Take 3 and 3 and multiply and get 9.
Use your teacher voice. You're teaching them. All right, time out. So I think you thought about right, but you wrote a 2. So a +4i and a -4i. It looked like a 2. Maybe that's just how you write your ones.
Oh, that's. Sorry.
Oh, okay.
That was.
-16i squared.
Yeah.
All right, so now do some talking. You're a teacher right now. So talk to them and tell them what you're going to do next.
I'm going to. This makes 0. And then these two get pulled out.
Alright, I am going to give her the ticket, but that was one of the worst
Sorry.
explaining jobs I've ever heard. She's supposed to explain it as she went because she was teaching you guys, and then she's supposed to turn around and say, any questions, class? But yeah, maybe she was just being shy because the microphone's on. It's not easy with the microphone on. Negative 12i and positive 12i do go away, so she was right saying that those add up to 0. She never quite explained what she did right here, though. This I squared gets replaced with a negative 1. And then negative 16 times negative 1 equals a positive 16. And they add up to 25. So look good. Everybody got 25, and if you didn't, you don't have any questions? Are we okay? All right. Alrighty, the time has come to talk about conjugates. Just like radicals, imaginary numbers don't want to be living in denominators. So we have a little trick to get our imaginaries out of the denominators. This trick is exactly like the trick you used with radicals. It's called using conjugates. Conjugates are simply opposites. So go ahead and write down this problem, and we'll talk about what we will multiply by to kind of conjugate or rationalize that bottom. Get all the i's out of the bottom. All right, so we are going to stick parentheses around this bottom because it is 2 terms, and we're going to make ourselves a group here and a group here. Very much the same as what you did before. Since I'm using that word conjugate, you do have to have a 1 plus 4i here. And that just makes those middles disappear when we go to FOIL. All right, on the top, it looks like we have a little distributing situation to do here. 2i times 1 is going to be 2i. And then 2i and 4i would be 8i squared. Whoop, whoop, whoop. Attention, everyone. We've got that I squared. What are we going to do? You're going to scribble out the I squared, put a negative 1 in its place, so it'll actually make it a negative 8. All right, on the bottom, just like when we did radicals, we don't have to do our whole FOIL because the inners and outers add up to 0. We only have to do the first matchup, 1 times 1 equals 1. And the last matchup, negative 4i and positive 4i is negative 16i squared. Whoop, whoop, whoop. We have an I squared, everyone. What are we going to do? Scribble out the I squared, make it equal to a negative 1, and negative 16 times negative 1 is positive 16. So let's express our final answer correctly. Nathan asked, do we always have to have that real number first? Yes. So in the numerator, I want to put that negative 8 first. Then I want to put the 2i, just to have it look more like a complex number. And what's my denominator, 17? And it's all been written nicely in standard form here. There's no i's in the bottom, which is good. All right. Let's see what's up next. Hello again. We are back. I went ahead and looked into your textbook to see if they were okay with you leaving it like that answer, if they split it into 2 fractions. So I'm going to let you know, Harp would be okay with you leaving in that answer. But I want you to be aware that these fractions can be split. The negative 8 can go over 17, as well as the 2i can go over 17. So it could be rewritten as negative 8 over 17 plus 2 over 17i. And they would actually stick that I up front. And you're probably, why are you showing us that, Harp? Why are you showing us that? Some of you are going to be taking an ACT, and this is what the multiple choice would look like. It would not look like this. But you can definitely see it's the same exact thing. It just gives both of the numerators a 17 as the denominator. Does that make sense? Alrighty. Alright, I found our next one. It's pretty easy. Do you want to try it by yourself, or you still want to do it with me?
I'm going to do it by myself.
Try it by yourself? Okay, well, go ahead and try it by yourself. We'll pause the video, give yourself some work time. If you do get stuck, you can look up. I'll have it set up for you up here. Hello, video people. I did this while we were on pause, but 5 times 1 was 5. 5 times negative I was negative 5i. Now, the bottom got tricky. It was a 1 times 1, which was 1, and a positive I and a negative I, which is negative I squared, but we had to really do some thinking there. We had 1 minus I squared. If you replace that I squared with the negative 1, you actually have 1 minus negative 1. Be careful. 1 minus negative 1 is 1 plus 1, so that denominator ended up being 2. So we kind of chatted, I'd be okay with you stopping here. 5 minus 5i over 2. If this was like a multiple choice question, probably like on the ACT, it'd be 5 over 2 minus 5 over 2i. That's how they would write that. Good, good? All right, then we're at our last problem of the day. We did great on time. I didn't know how this would go. Go ahead and jot it down. I wanted to do this one because it's a much larger one. It's going to take much longer to foil. We'll just do it together since it is so much bigger than the other ones we've seen. Still going to need that conjugate because we still have that denominator that's 2 terms. So put our conjugate right here. We'll put our conjugate right here. But we're actually going to have to group this top like so because our top is not going to just be a distributor. Our top's going to be a FOIL. There's 2 terms up there. All right, what's the conjugate we should use? Do 5 minus 2i, or should we do 3 plus 2i? Yeah, because it's the denominator we're working with. So it's 3 plus 2i you're going to put on the top and bottom. Whatever you put on the bottom, you have to put the same exact thing on the top. Let me just actually start with my bottom. I know that sounds crazy, but it's less work. So the bottom, we're just going to do this matchup. 3 times 3. Get 9. We're going to do a negative 2i with a positive 2i and get negative 4i squared. Whoop, whoop, whoop. What are we doing with that I squared? Scribbling it out, replacing it with a negative 1, which makes this a positive 4. It's going to be a 13 for our bottom. All right, top's going to be much more work, though. We have to do the whole FOIL. Since these two are not conjugates of one another, we must do the whole FOIL. 5 times 3 is 15. 5 times 2i is 10i. 2i and 3 is 6i. And 2i is 4i squared. Whoop, whoop, whoop. What are we doing with that 4i, or that I squared? Scribbling it out, making it a negative 1. So that's actually going to be a negative 4 when we go to combine our like terms. All right, let's see what our final answer looks like. 9 plus 4 on the bottom is 13. On the top, I can add that 15 and that negative 4, which would be 11. And then I can add this 10 and this 6, which would be 16i. So that's okay with where you want to leave it if you want to write it more scholarly. 11 over 3 plus 16 over 13i. All right, so we are going to be done. Your homework is a worksheet, so I want to show the people on the video if I got it captured here or not. It looks like I don't have it captured. So if you are absent, just get that worksheet for me when you get back, or maybe I'll find a way of sticking it in Polaris as a PDF. Okay? Thanks for watching the video.